Hello everyone, in this video we're going to explore topic 9.8 of AB Calculus BC. Find the area of a polar region or the area bounded by a single polar curve. Alright, so suppose I have the polar curve R equals f of theta E sketched below. Now I'm going to partition these regions into n sector. Alright, so each sector right here represents as this picture right here. Alright, we have the formula part over whole equals part over whole. So we're going to set up a proportion using this formula. Alright, we know that this one is the angle theta, right, of the sector of the circle, right? This sector is the part of the circle. So we have angle theta over 360, which is 2 pi, right, equals the area of the sector equals AS right here over the area of the circle is going to be pi r squared, right? Now I need to calculate the area of the sector. It's going to be pi r squared times theta divided by 2 pi, right? So I'm going to simplify this one. I have the area of the sector is going to be 1/2 r squared times theta, right? Now r is given by f of theta right here, right? So I just replace r with f of theta, right? So I have 1/2 f of theta square times theta, right? Now suppose I have infinitely sectors right here, right? Which means n goes from 1 to infinity, right? So I'm going to use limit notation. So I have limit when n approaches infinity of this guy right here when I goes from 1 to infinity, right? And it's going to be right here. Now I'm going to use the integral notation to represent these limits, right? So it could be 1/2 times integral from alpha to beta of f of theta squared d theta, right? That's why we have this theorem right here. Error in polar coordinates. If the function f is continuous and non-negative on the interval alpha beta, where beta minus alpha, which is the angle right here, I call this theta, right? From 0 to 2 pi, then the area of the regions bounded by the graph of r equals f of theta between the radial lines theta equals alpha and theta equals beta is given by this one. Alright, now let's take a look at the first example. Finding the area of a polar region. Find the area of one parallel of the rose curve given by r equals 3 cosine 3 theta. Now, first we need to graph this rose curve. Alright, if you want to review how to graph this rose curve in AP Pre-Calculus, please check out the link in the description below. Alright, so I have r equals 3 cosine 3 theta, right? And remember, you have the formula r equals a cosine n theta, right? If n is r, the pedal symmetric about the x-axis, right? Now A equals 3. This is the length of the pedal, right? So you have one circle right here, two circle, and three circle right here. The length of the pedal is 3, right? Now we're gonna use the t-charge. This one is angle theta. This one is the radius. We're gonna start from the angle theta equals 0, right? Then substitute 0 for theta into this one. You have 3 cosine of 0, which is 3, right? Because cosine of 0 equals 1, right? If we let the radius equals 0, which is right here. And then we need to find the angle theta right here, right? So how do we do this one? We substitute 0 for all into this equation right here, right? So we have 3 cosine 3 theta equals 0, right? So cosine 3 theta equals 0. Now 0 actually cosine of n pi over 2, right? So then you have 3 theta equals n pi over 2, right? Theta equals n pi over 6, right? Now we're gonna focus on the counterclockwise direction, right? Which means the angle is positive, so n is a positive integer, right? So n equals 1. We have angle theta equals pi over 6. N equals 2. We have angle theta equals pi over 3, right? But we don't focus on this one much. We're gonna find the first angle right here. Theta equals pi over 6, which is right here, right? So we have the first pedal is going to be something like this. And we need to reflect this one over the x-axis, so it could be something like this. So to calculate the error of this one, I just take the error of this guy, and then I'm going to multiply by 2, right? Sorry for my mishap. The radius of the pedal should be 3, not 10. Now I'm going to use this formula, right? So I have alpha is going to be 0, beta is going to be pi over 6, right? F of theta is actually the radius, right? It's going to be 3 cosine 3 theta, right? So I'm going to substitute over here. A equals 1/2 the integral from 0 to pi over 6 times 3 cosine 3 theta all together square d theta. Now we just calculate the error of the upper half of the pedals, right? So then we need to multiply by 2 to get the error of the whole pedal, right? So this guy turns out to be the integral from 0 to pi over 6. Now 3 square equals 9. I put 9 in the front, right? 2 and 2 right here cancel out. Cosine 3 theta square. We're going to use the formula cosine square of s equals 1 plus cosine 2s over 2. So this guy turns out to be, I'm going to bring 2 to the front, right? So it could be 9 over 2. And it's going to be 1 plus cosine 6 theta d theta, right? And then I'm going to check antiderivative of this one. So it could be 9 over 2 times theta plus 1 over 6 sine of 6 theta evaluated from 0 to pi over 6, right? Now I'm going to substitute values, right? So it could be 9 over 2 times pi over 6 plus 1 over 6 sine of pi, right? Subtract 0 plus 1 over 6 sine of 0, right? So this guy turns out to be 9 over 2 times pi over 6. Sine of pi equals 0, right? And this one equals 0, so the answer is 9 pi over 12. Divide the top bottom by 3, so it could be 3 pi over 4, right? Now I'm going to bring up the calculator to check our work, right? So I just press calculate, press menu, calculus, integral right here, from 0 to pi over 6, right? And press enter. It's going to be 2.35619. This guy actually 3 pi over 4, right? Press Control enter. It's going to be the same thing, right? So this one is correct. Now let's move on to example number 2. Find the area bounded by a single curve. Find the area of the region lying between the inner and outer loops of the limmason, or equals 1 minus 2 sine theta. Alright, so we have the radius equals 1 minus 2 sine theta. Alright, so we're gonna start from the origin. The area of the shaded regions is the area of the whole thing right here. Subtract the area of the inner loop, right? So we need to find the lower bound and upper bound of the inner loop right here, right? So suppose the point at origin, we have radius equals 1 minus 2 sine theta. And when the point is right at the origin, the radius equals 0, right? So we have 2 sine theta equals 1, right? Sine theta equals 1/2, right? So theta equals pi over 6 and 5 pi over 6, which is this guy and this guy, right? So this one is for inner loop. So we need to find the lower bound and upper bound of the outer loop right here. Now remember that the point travel this way. So on the outer loop, this one is the lower bound, right? And then this go back to the original point right here. Original point right here actually complete a full circle, right? So it should be pi over 6 right here plus this one is 2 pi, right? So pi over 6 plus 2 pi is going to be 13 pi over 6, right? So this one is the inner loop and outer loop should be 5 pi over 6 and 13 pi over 6, right? So we have the area of the region is the area of the whole thing right here. Subtract the area of the inner loop, right? Now we're gonna use the formula sine square theta equals 1 minus cosine 2 theta over 2, right? Alright, so this guy turns out to be 1/2 the integral form 5 pi over 6 to 13 pi over 6. Expand this one using the complete square formula, right? So it could be 1 minus 4 sine theta plus 4 sine square theta. But sine square theta, I'm going to use this formula, right? So it's going to be 1 and 2 right here. I'm going to combine. So it turns out to be 3 right here. Similarly, I have 1/2 integral from pi over 6 to 5 pi over 6 of 3 minus 4 sine theta minus 2 cosine 2 theta d theta, right? Now I'm going to check the antiderivative of this one, so it could be 1/2 times 3 theta plus 4 cosine theta minus sine 2 theta, right? Evaluated from 5 pi over 6 to 13 pi over 6 minus 1/2 times 3 theta plus 4 cosine theta minus sine 2 theta. Evaluated from pi over 6 to 5 pi over 6, right? Now I'm going to substitute 13 pi over 6 and 5 pi over 6 into this one, so it's going to be 1/2 times 3 times 13 pi over 6, which means 13 pi over 2, right? Cosine of 13 pi over 6 is root 3 over 2, right? So I have 4 root 3 over 2. Now sine of 13 pi over 6, which means sine of 13 pi over 3. So it's going to be root 3 over 2, right? So it could be negative root 3 over 2 minus 3 times 5 pi over 6, which means 5 pi over 2 plus cosine of 5 pi over 6 equals negative root 3 over 2. So I have negative 4 root 3 over 2. Now sine of 2 times 5 pi over 6, which means sine of 5 pi over 3, right? So it's going to be negative root 3 over 2, and negative side right here, it turns out to be positive root 3 over 2. Minus 1/2 times 3 times 5 pi over 6, which means 5 pi over 2. Cosine of 5 pi over 6, which means negative root 3 over 2 times 4, it could be negative 4 root 3 over 2. Sine of 5 pi over 3 is going to be negative root 3 over 2, and negative side here becomes positive root 3 over 2 minus 3 times pi over 6, it could be pi over 2. 4 times cosine of pi over 6, it could be root 3 over 2, so it could be plus 4 root 3 over 2. And then sine of pi over 6 times 2, it could be pi over 3, which means root 3 over 2, and it's going to be negative root 3 over 2, right? Now if you simplify this one, the answer must be pi plus 3 root 3. Alright, now we're going to use calculator to check our work. After you input the expression, you press enter. The answer is pi plus 3 root 3, right? Which is correct. Now let's learn how to find the points of intersection of polar graphs. Alright, locate the points of intersection of the polar graphs. R equals 1 minus cosine theta, and R equals 1 by solving this one algebraically, right? So we just equate this guy and this guy, right? So we have 1 minus 2 cosine theta equals 1, right? So 2 cosine theta equals 0, right? So cosine theta equals 0, right? So theta equals pi over 2 and 3 pi over 2, right? Suppose the domain should be 0 to 2 pi, right? So we have the point of intersection is going to be 1 comma pi over 2 and 1 comma 3 pi over 2, right? Now use your graphing calculator to scaffold graphs. What do you notice about the points of intersection? Alright, so I'm going to bring up the calculator. Press graph right here. You need to squeeze this one into the polar coordinate, right? So I'm going to press menu, graph entries, polar right here, right? So the first equation should be 1 minus 2 cosine theta, right? Then you're going to press enter. It's going to be something like this, right? If you want to zoom in, just press menu number 4 and number 3 right here. Alright, now for the second equation, r equals 1, you need to press tab right here. You just put 1, press enter. This could be the circle equation. This could be right here. Now observe that you have actually 3 intersections. The first one right here is 1 pi over 2. This one is 1 3 pi over 2, which is we already found in the first equation. Now we miss this one. Why we miss this one? It's just because when you have the radius 1, you also have the radius equals -1. Alright, so you have 1 minus 2 cosine theta equals -1, right? So you have 2 cosine theta equals 2, right? So you have cosine theta equals 1. And then theta equals 0, right? So you have the coordinate point of intersection is going to be -1, 0. Right, now let's move on to the last one. We're going to talk about the arc length of a polar curve. You have the theorem right here. Alright, the arc length equals the integral from alpha to beta of the square root of the radius square plus dr over d theta square d theta, right? So let's take a look at example number 3 right here. First, we need to take the derivative both sides with respect to d theta, right? So have dr over d theta equals cosine theta, right? So when you square this one, it turns out to be dr over d theta equals cosine square theta, right? Alright, so the arc length of this one is the integral from, suppose the domain of the cardioid right here is from 0 to 2 pi. So you have 0 and 2 pi right here. The square root of r square, which means 1 plus sine theta altogether square plus cosine square theta d theta, right? And then you just print up the calculator, press on right here, hit calculate. You press enter. The answer is 8, and it's your turn to solve. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.